Hello friends and students. So now we will solve the problems given in the second exercise of the chapter Surface Areas and Volumes. So in this exercise we will solve the problems wherein we try to calculate the volume of different shapes and sizes. Right? So I have already listed the formulas. So the volume of a sphere is given by 4 by 3 pi r cube, hemisphere, cone and cylinder. So before I proceed, make sure that you join the Telegram group for 10th Mathematics. The link has been given in the description so that you will keep yourself updated about all the videos, lecture videos and 10th Mathematics. And do not forget to like, share and subscribe and press the bell icon to get notifications of further uploads. So moving on with the first problem. The first problem states that a solid which is in the shape of a cone is standing on a hemisphere with both their radii being equal to 1 centimeter, and the height of the cone is equal to the radius. Find the volume of the solid in terms of pi. Right? So therefore there is a hemisphere and on it you have a cone, and what has been given? The radius is 1 centimeter as well as the height is also 1 centimeter. So the height of the cone. So we need to find the volume. So what is the volume? The volume is nothing but the hemisphere plus the volume of the cone. So therefore volume of the entire solid is equal to volume of, I'll write V for volume, for hemisphere I'll write HS, plus volume of cone. So what is volume of hemisphere? It is 2 by 3 pi, r is 1, right? So it is into 1 cube, plus what is volume of the cone? It is 1 by 3 pi, r is 1 square, into height also is 1, right? So we get 2 by 3 pi plus 1 by 3 pi is pi centimeter cube. A very simple problem. So let's move on with the second one. A model which is nothing but a cylinder with two cones attached to its end is done by an aluminum sheet. The diameter of the model is 3 centimeters and the length is 12 centimeters. So what has been given? There's a model which is being created, which is in the form of a cylinder, and you have two cones on either sides. The total length of this model is 12 centimeters. So this is 12 centimeters, the total length, from one end to the other end. And the diameter of the model is 3 centimeters. So the diameter is 3, so this is 3. And what is the radius? The radius is 1.5 centimeters. So if the diameter is 3, the radius is 1.5 centimeters. Now if each cone is of height 2 centimeters, so the height of the cone, so this is 2 and this also is 2. So now what is the height of the cylinder? It is 12 minus 4, so you have 8. So the volume of this solid is volume of the cylinder plus volume of one cone here plus the other cone here, and these two cones are identical. So volume of solid is nothing but equal to volume of cylinder plus 2 times the volume of cone. So what is volume of cylinder? It is here, it is pi into r. What is the radius? Radius is 1.5, isn't it? So it is 1.5 square into h is 8 plus 2 into volume of cone. So what is volume of cone? It is 1 by 3 into pi into r square. So what is r square? It's again 1.5 square into h. h is 2, the height of the cone. Now what is common here? The common is pi into 1.5 the whole square. So if I take this common, so I am left with 8 plus, so this is 4 by 3. So what do we get? If we do this calculation, we get a value as 66 centimeter cube. Alright, so a very simple problem where we had to find the volume of the solid, which is nothing but volume of the cylinder plus volume of two identical cones. Now problem 3 is a very sweet problem because it's a problem related to gulab jamuns, and I guess all of you, most of us love eating gulab jamuns. Now a gulab jamun here is in the form of a cylinder. So if it is in the form of a cylinder with two hemispheres on each end, so it's been given that from one end to the other end, the length is 5 centimeters. Okay, so this is the shape of a gulab jamun. It's like a cylinder with two hemispheres on either sides. Alright, and now the diameter is 2.8. So diameter is 2.8. So if the diameter is 2.8, then the radius is 1.4. So the radius here is 1.4, and this is the same radius of the cylinder too. So therefore, the radius is 1.4, so this is 1.4, and this also is 1.4. So what about the height of the cylinder? The height of the cylinder is 5 minus 2.8. So 5 minus 2.8 will give me 2.2 centimeters. So now, what has been stated in the problem? It's been stated that a gulab jamun has sugar syrup up to 30% of its volume. Now, how much sugar syrup is present in 45 gulab jamun? So let's try to find the volume of one gulab jamun. So volume of one gulab jamun is volume of cylinder plus 2 into volume of hemisphere, isn't it? So this is one hemisphere and the other hemisphere. So what is volume of cylinder? It is pi into r, which is 1.4 square, into h is 2.2, plus 2 into hemisphere. So it is 4 by 3 pi into 1.4 the whole cube. So this is the volume of one gulab jamun. Right? So it is 4 by 3 pi 1.4 the whole cube plus pi 1.4 the whole square into 2.2, and what do we get? We get a value as equal to 25.05 centimeter cube. So this is volume of one gulab jamun. So now what do I need? I need volume of 45 gulab jamun. So volume of 45 gulab jamun is nothing but 45 into 25.05. And now what do I need to find? I need to find the volume of the sugar syrup content. So it's been given that 30% of the gulab jamun is made up of sugar syrup. So 30% means more what? So I have to just multiply it by 30 by 100, or I have to multiply it by 0.3. So when I do that, so when I do this calculation, I will get 338.184 centimeter cube. So this is the volume of sugar syrup present in 45 gulab jamuns, which is 338.184 centimeter cube. So the next one is a very interesting problem. There's a pen stand made up of wood, and it is in the shape of a cuboid with 4 conical depressions to hold the pen. Now the dimensions of the cuboid are, so you have a cuboid which is present, and the dimensions of this cuboid is given. The dimensions are 15 centimeter is to 10 centimeter is to 3.5, and so there are conical depressions, 4 of them, so that you can actually make a pen stand on it. Right? The radius of the depression is 0.5, so this radius is 0.5 centimeter. And what about the depth of depression? The depth of depression is 1.4 centimeters. So what do I need to do? I have to calculate what is the volume of the wood stand. So to calculate the volume of the wood stand, I calculate the volume of the cuboid minus the volume of 4 cones, because all these cones are identical, there's a depression which has been made. So the cone area has been removed out. So I have to subtract the volume of these 4 cones which are identical. So volume of this pen stand equals volume of cuboid minus 4 times volume of cone. So what do I get? Volume of cuboid is 15 into 10 into 3.5 minus 4 into, what is volume of cone? It is 1 by 3 into pi into, radius is 0.5 the whole square into, the height of the cone is 1.4. Okay, so when I do this calculation, so here the volume of the cuboid, we get 525 centimeter cube, and here we have volume of one cone, so it's going to be 4 into 0.366. Okay, so now 4 into 0.36 has to be subtracted from 525, so we get the volume of the pen stand, which is 523.54 centimeter cube. So this is the volume of the pen stand. Problem 5 is an interesting one. A vessel is in the form of a cone. So there is a vessel in the form of a cone, and then what has been done? It's been filled up to the brim. So it's been filled up with liquid up to the brim with water, and the radius is 5. So the radius is 5 centimeters r. And what about the height? The height is 8. So it's been filled with water. So in it, what am I dropping? I'm dropping lead shots, which are circular. So they are actually spheres, and their radius is 0.5 centimeter. Okay, so one by one, we are actually dropping these spherical lead shots into the cone filled with water. And then what happens? Since the water was filled up to the brim, when you drop these lead shots, water flows out. So how many lead shots am I dropping inside this cone? Such that 1/4 the water flows out. So we would want to know how many lead shots have been dropped. So first let us try to find the volume of the cone. So volume of cone is 1 by 3 into pi into r is 5 square into 8. So this is 200 by 3 pi centimeter cube. Okay, so how much of water flows out? 1/4 the water flows out. So water flowing out, the volume of water which flows out is 1/4. So 1/4 200 by 3 pi, which is nothing but 50 by 3 pi centimeter cube. So this is the volume of water which flows out, right? And this volume of water which flows out is equal to the volume of the lead shots which have been dropped inside. So now we have to equate these two, and then we'll be able to find out the number of lead shots. So volume of one lead shot is given by 4 by 3 pi into 0.5 the whole cube, right? So where r is 0.5. So this is the volume of one lead shot. Okay, so if we calculate, we get this as pi by 6 centimeter cube. So how many lead shots are there? So we need to know the number of lead shots. So n into pi by 6 equals 50 by 3 pi. Alright, so pi gets cancelled, 3 and 2, so 2 into 50 is 100. So you have 100 lead shots, spherical lead shots, which have actually been dropped into this cone which was filled with water, and then we had 1/4 the water flowing out. A very interesting problem. Now moving on to the sixth one. A solid iron pole, which is nothing but a cylinder of height 220 centimeters and having a diameter of 24 centimeters. It is surmounted by another cylinder having a height of 60 and a radius of 8. Find the mass of the pole if 1 centimeter cube of iron has 8 grams of mass. So it's a very simple problem. So we have a cylinder here, and on top of it there is another cylinder. Very simple. So the height of this cylinder is 220, and then the diameter is 24, so the radius is 12. Now on it you have another cylinder. What is the height? The height is 60, and here the radius is 8. So what is the volume of the entire solid? The volume of entire solid is volume of this cylinder plus this. Okay, so volume of solid is volume of the first cylinder, which is pi into r is 12 square into H220 plus pi into r square, which is 8 square into H is 60. So this is the total volume of this solid. So that is equal to 111,634.5 centimeter cube. Right? It's a big number. So this is the volume of the cube. So now it has been given that we need to find the mass of the pole if 1 centimeter cube of iron has 8 grams mass. Okay, so this is the total volume of the solid. So we know that mass equals density into volume. So 1 centimeter cube of iron has 8 grams mass. How much does 111,634.5 centimeter cube have? So it's going to be 8 into 111,634.5, and this gives us a value of 893,074.285. Okay, so it's a big number. Or if I divide this by 1000, so I get 893.074 kgs, which is the approximate value. Right. So 893 kgs is the approximate volume, that is the mass of the given solid which we have found out. So this is how we can find. So the only difference here is that we need to find the mass, and the density has been given here. So therefore we need to multiply 8 with the total volume of the entire solid, and we'll be able to find out the approximate mass of the given solid in kgs when I divide this by 1000. Problem 7 is a very interesting one. It states that there is a cylinder, and the cylinder height is 180 centimeters and its radius is 60. Alright, so it's been filled with water first. So now inside this we are actually inserting a solid. Now we are inserting a solid. Now how does this solid look like? This solid is nothing but a hemisphere, and then on top of this is a cone. So this is a hemisphere, right? On top of this is a cone. So this is a solid which is placed inside. So some of the water flows out. So now we would like to know the amount of water which still is present in this cylinder. So what is the water which is still present in the cylinder? It is nothing but the volume of the cylinder minus the volume of this solid, which is nothing but the volume of the cone plus the hemisphere. Now what are the details of the solid which is being given? The height is 120. So the height of the cone is 120 and the radius is 60. So this also is 60 here. Right? So we would like to find the water. The volume of water left is nothing but volume of cylinder minus volume of this solid. So it is volume of cone plus volume of hemisphere. Very simple. So what is volume of cylinder? It is pi into r square. It's 60 square into h is 180 minus volume of cone, which is 1 by 3 into pi into r is 60 square into h 120 plus volume of hemisphere, which is 2 by 3 pi into 60 cube. Right, because the radius of the hemisphere is 60. So when we do this calculation, we get a value as 1131428.57 centimeter cube. So, or we can divide this. So if I want to convert this to meter cube, so what do? I know that 1 meter equals 100 centimeters. So I have to divide this by, divide this by 100 cube, right? So that means 1, 2, 3, 4, 5, 6. So I bring the decimal point, shift it to left. How many places? By 6 places, because I am dividing it by 1 followed by 6 zeros. So I get 1.13 meter cube. So this is the volume of water which is left inside the cylinder. Moving on with the 8th problem, again an interesting one. So it states that a spherical glass vessel has a cylindrical neck. So there is a glass vessel and it has a cylindrical neck. So this is in the shape of a cylinder, and the neck is 8 centimeter long. So this is 8 centimeter long, and it has a diameter of 2 centimeters. So this is 2 centimeters. So what about the radius? So let me call this as R1. The radius of the cylinder is 1 centimeter, and the diameter of the spherical part is 8.5. So the diameter is 8.5 centimeters. So what is the radius of the sphere? The radius of the sphere, let me call this as R2, which is 4.25 centimeters. By measuring the amount of water it holds, a child finds that the volume is 345 centimeter cube. Is it correct? Right, so we just have to find out if this is the volume of this solid figure. So now the volume of the solid is nothing but the volume of sphere plus volume of cylinder. Now what is volume of sphere? The volume of sphere is 4 by 3 pi into, the radius is 4.25 the whole cube. Right, so this is the radius of the entire sphere, isn't it? Which is R2 plus the volume of the cylinder. So volume of the cylinder is pi into R square. So it's R1 square, which is 1 square into H is 8. So this is the volume of the cylinder. So when I calculate, we get the volume as 346.8 centimeter cube. So this is the volume of the solid, but the child has measured it as 345. So there is a difference, a small difference. So therefore, the volume of the solid which has been measured by the child is wrong, so is incorrect. Okay, so that's the answer for problem 8. The next exercise is even more interesting. Now here in this exercise we have only found the volume of different solids, but in the next exercise where we consider problems, you have a solid and the shape of the solid is changed, whereas the volume remains the same. So how do we find different values such as radius, height, etc., etc.? It's an even more interesting exercise, and we shall take it up in the next video segment. Do not forget to like, share and subscribe, and press the bell icon to get notifications of further uploads. And also do make sure that you join the Telegram group 10th Mathematics. The link has been given in description so that you get all the latest uploads of 10th Mathematics. And thanks for watching.